And good morning everyone. It's good to see the familiar faces but also a few new faces to the audience. So as Peter said, this first session is really to give you an overview of the different R&D which Angus Australia is involved in. And this, so we'll go through and have a look at a range of different programs which we're currently available in, and we probably won't have time to get our teeth into a lot of them, but the point of this session is really just to give you some awareness of the different type of R&D activities which Angus Australia is doing on a day-to-day basis. Just to set some context before we start looking at it in specific detail, is really over the last decade or so that the role of Angus Australia has evolved. So, and that's not unique to Angus Australia, it's unique to a lot of breed organisations, registered breed organisations in different species, and also not only domestically but internationally. And in particular, Angus Australia's role in the industry, I guess, has kind of changed from our traditional role maintaining a kind of pedigree herd book to really evolving into a modern member-based innovation company for Angus cattle and Angus beef. So this is a big focus now of Angus Australia, both from a board and a management level. And as a result of that, I guess, and in association with that evolution, we've now got a far larger involvement and also investment in research and development and adoption than we previously may have had. So it's really in this context. And the R&D which we're involved in now is quite a wide-ranging program, which you'll see as I start going through the different activities that we're doing. But it's a combination of both things that we're doing in-house and also more and more now collaboration with other R&D organisations, and that's both R&D organisations domestically plus also internationally. So more and more as we go forward, collaborating with our colleagues and things in overseas countries that are working in similar areas. Now, why are we involved? I guess, why has this evolution occurred? And there's two major reasons why we're investing and involved in this area. The first one really, and the number one and main objective of why Angus Australia as an organisation is involved on behalf of you as our members, is to enhance the value and profitability of Angus genetics throughout the beef supply chain, whilst doing it in a sustainable fashion. So we can all focus on just maximising our rate of genetic improvement, but we need to do it in a sustainable way where we're maintaining genetic diversity along the way. So ultimately our number one reason why as an organisation we're involved in this is to enhance the profitability of Angus genetics, which both returns more income to our members and their customers, but then also increases, I guess, the demand for Angus genetics into the future. So that's the number one objective. The second objective is also just to ensure that our members, so those breeders of Angus cattle in Australia, have access to world-leading genetic evaluation technologies. So we want to make sure that you as members are armed with the latest and greatest technologies so that you can do the best possible job within your enterprises. So that's just to put some context. I'll now go through, I guess, and start to show you some of the different R&D which we're involved in. Some of this you will be fairly familiar with, for those that have been around Angus Australia for a while. Some of it, I suspect, a bit of the collaboration, you won't be all that aware of. So particularly the main activity which we're involved in the R&D space is around the Angus sire benchmarking program. So the Angus sire benchmarking is quite well promoted through our different communication channels, and it's effectively a large-scale young sire progeny test program which we're running as an organisation, where we're going through and progeny testing 40 sires each year, where they're being joined by fixed time AI to around 2,500 cows. So through fixed time AI, we're aiming to join 40 sires to about 60 heifers each, with conception rates end up with 40 progeny, 20 heifers, 20 steers ideally, which by the time we get through the production chain, we make sure we've got hopefully at least 12 to 15 progeny by each sire of each sex. So the sire benchmarking program, and many of you have had bulls in that, the objectives of that is to go through and first of all collect progeny test data on modern Angus bulls. So we're trying to collect up-to-date information on modern Angus genetics, but particularly for the hard-to-measure traits. So there's a lot of progeny testing just done within our members' operations for the routine type of traits which are easy to collect on farm. But the big focus of the CSIRO benchmarking program is on these harder to measure traits such as feed efficiency, carcass and meat quality within the abattoir, and heifer fertility. So that's the big objective, is to really get good information on those hard to measure traits, which is difficult for our members to collect within their operations. The second objective, and the next session we're going to talk about today, gives you some of the early outcomes of this, but it's to enable us to go through and actually just validate our Angus breed plan analysis, and most importantly to go through and identify areas where we can refine and improve the breeding values which have been produced on Angus cattle. So it's a key area where we've got a whole range of young sires which have EBVs. We can then go through and look at how have their progeny performed, have they performed in accordance with how their EBVs were predicting, and identify areas where we can improve what we're doing in that space. And thirdly, but not leastly, the other major objective of the CSIRO benchmarking program is to develop a really useful resource population for DNA. So as DNA, and we'll talk a lot today about the different genomic technologies which are available. The third objective is to have this really useful resource population of animals with comprehensive performance information, particularly for the hard to measure traits, plus DNA information which we can use to make sure that we're at the cutting edge of the different genomic technologies which are available. So they're the three major reasons, I guess, why we're investing in this program. And it's really starting to become the centrepiece of all our R&D that we're doing. And as you'll see throughout the rest of this presentation, there's a lot of other research and development which is now being dovetailed into the CSIRO benchmarking program by way of increasing the benefits which we're receiving. To give you an idea where it's up to, so that the CSIRO benchmarking program, at the moment, as we speak, are in the process of joining the 8th cohort. So the program started in 2010, back with the joining of the first cohort. And we're now, as I say, in the 8th joining. The first 4 cohorts have now been fully completed, so the animals have gone through the whole production chain. Cohort 5 is at a stage where the steer progeny are all being slaughtered now, so between now and the end of the year, most of Cohort 5, the carcass data will be collected, and the heifers have all calved down in this spring as maiden heifers. Cohort 6 are our kind of yearlings, so the steers within that program are now going through and starting their feed efficiency testing out at Salimba, so just west of here out of Kingstown. So they're starting to roll into that program. And Cohort 6 heifers are currently being joined to calve down next spring. Cohort 7 are the calves which have just hit the ground this spring, so we've now got all the birth data on those. Cohort 8 is the joining which we're currently doing, so the AI program. We do have funding now to the end of Cohort 8, and we're currently in discussions, I guess, with Meat and Livestock Australia to continue the program forward into the future, and it'll certainly be our intention. I haven't acknowledged at the start, which I should have, that all the CSIRO benchmarking program is jointly funded by MLA through the donor company scheme. So it's a federal pot of money which we're utilising to co-invest with Angus Australia in this program. So that's where we're up to across in terms of progress. To give you an idea also then about how much information has now been collected. So this shows you how much performance information has been collected across the different traits now. So as you can see, we've now, with the joining of Cohort 8, we've hit our 300th sire. So there's now been 300 sires, and that represents around 6,000 progeny. So across some of the birth traits, we have 6,000 phenotypes or performance records. Starting to see quite a large number of weight traits. But most importantly, for the hard to measure traits, so some of our abattoir data now, we're starting to approach 2,000 records. So we're starting to talk in these hard to measure traits not about hundreds of records, but about thousands of records. And that starts to then become a very useful data set on which we can start to do some things when we start looking at the genetics and whether these traits, what the heritability of them is, what's the correlations with other traits. We're starting to get to a very useful data set for these hard to measure. So there's a comprehensive amount of performance information which has now been collected, and given we've only just finished, I guess, Cohort 4, in terms of the full collection, this data will grow now very much as we go through and collect data on the Cohorts 5 to 8. All these calves, as I've mentioned, have also got DNA information. So you can see now the numbers of animals which we have good DNA profiles on. So there's there's the 6,000 calves. All the calves in the program have a low density test. So this here is just the number of SNPs, or the number of gene markers which have been collected on these animals. So on these 6,000 calves, they've all got around a low density with around 20,000 SNPs or gene markers, whereas the sires have all got a high density profile. So they've all got around, on average, 60,000 SNPs. So as well as the performance information, we've now got good DNA on all these animals, and it's forming a very useful reference set for our genomic work. So that's the SIRE benchmarking program, I guess, and that's the core key bit of activity and investment which Angus Australia is involved in. But alongside of this, we're now doing a lot more collaboration with different R&D organisations, so both internationally and domestically. And there's representatives, it's good to see, from a lot of these organisations here today. But as an example of the kind of organisations which we're working with, so the Animal Genetics and Breeding Unit and the Agriculture Business Research Institute, both based out here at the University of New England, we work with on a very almost day-to-day basis in the delivery of our Angus breed plan genetic evaluation and making improvements to that. Our two DNA service providers, so our partner organisations that we partner with to deliver the genomic technology, being Zoetis and GeneSeek. Vetoquinol, who have a big involvement in the reproduction program, our AI programs within the SIRE benchmarking program, and are now starting to do some R&D into different ways that we can improve the results from our artificial breeding programs. Doing a lot more work on a day-to-day basis with CSIRO, also University of New England, the New South Wales DPI, Charles Sturt University. We've just formed a partnership with them, and we're really looking forward to what that's going to deliver to Angus Australia and also our members. And as I said, also more internationally now, working with particularly our colleagues in North America, so the American Angus Association and Canadian Angus Association, but also a lot more researchers in North America as well. One of the things which I've touched on before, but a lot of this research where we're doing with these in collaboration is as an add-on to the SIRE benchmarking program. So because we've now got a really core SIRE benchmarking program where a lot of performance information and DNA information has already been collected, we're able to then, a lot of the R&D companies are coming to us and saying, well, can we also do this part of our research on your SIRE benchmarking cattle, because you've already collected that base set of data, and we can just add on with these newer traits and newer areas. So it's becoming an area which we probably didn't envisage it'd grow as much, but it's becoming a really key part where we can get a lot of extra value for our investment in the SIRE benchmarking program by adding on this research. So I'll give you a snapshot of some of this collaborative work. As I said right at the start, we won't get a chance to probably get our teeth into a lot of it, but it'll give you some idea as to what the different add-on programs are. So the first one is a program which we're doing with the CSIRO. Dr. Brad Hine, who a lot of you may know, is based down here at Chiswick, just out of Uralla. He's kind of been leading the work in this area. And we're really focusing on some of the research behind breeding more resilient Angus cattle. So within this, I guess, how do we define resilience? And we're really trying to look at and to identify those animals which can maintain productivity when placed under stress. So in particular, I guess that the main stresses being whether they're placed under a disease or an environmental challenge, those animals which hold on and maintain their productivity versus those animals which tend to fall over. So within this program, the CSIRO have actually developed, in association with some of their colleagues in Canada, a way of measuring, if you like, objectively resilience, or an assessment of an animal's resilience. So we have measurements now taken on some animals in cohorts 2 and 3. So there's about 1,150 animals where we have some resilience measurements. We've just gone through and collected another 1,250. So we did the analysis of this, and I'll show you some of the early results, but it showed promise and warranted, I guess, further investment in this area. So we've gone through and collected measurements on cohort 6. They're all at the CSIRO lab at the moment. They take blood out of the jugular of each of the calves and then look at the antibody levels within it. They also look at this skin fold reaction. So within the tail, if you can kind of see the tail up here, and you see the measuring, there's some calipers here. They actually jab a little bit of vaccine in the tail and measure how much response. And those animals which have a greater immunity or a greater immune response get a bigger lump. So there's a lump that's formed, and they measure the change in the skin fold thickness in the tail here. So effectively measuring those animals which get a bigger lump and more immune response. So that's one way they're measuring it. They're also looking at some of the stress hormone levels of animals, the weight gain and weight loss over this yard weaning phase, so whether they're losing weight or maintaining weight or even putting on weight in some cases, and also temperament. So a big relationship between animals' resilience and temperament. Ross?
Is any follow-up being done like on their feedlot induction stage on that project?
Certainly. So on cue with the next slide, there are some of the work. So I'll show you some of the early results, and these are only a snapshot, but it has all been followed through into the feedlot, which I'll show you towards the bottom of this. So first of all, to do with immune competence, I guess that the earlier work has shown when we look at these measurements, there are differences between animals, and those differences are under genetic control, or some of those differences we can put down to genetic differences. So we have heritabilities here, and again, we're only working off 1,150 records at this stage, so it's a small data set, but it is showing that this trait is likely to have moderate heritability. And that's where it's justifying us to go in and collect more information and invest more in this to increase our estimates. Importantly though, as well as being shown to have some genetic differences between animals, it's also favourably correlated with stress responsiveness. So those animals with better immune competence had better ability to handle stress and also superior temperament. The other bit that was also done is these steers that were all measured for animal resilience over this yard weaning phase were then followed through to the feedlot. So they went through their usual feed efficiency testing at Talimba, but then were finished up at Ranges Valley for 170 days. And Ranges Valley were very helpful in being able to provide us with comprehensive details about the health treatments and the sickness and the deaths and things which occurred in these animals. So based on that, CSIRO to analyse that and show the animals that had the superior immune competence measured through those blood level, antibody levels and also the skin fold thickness, also had significantly reduced health associated diseases while up in the feedlot, significantly fewer mortalities, and when they put some economics around that, they actually divided these steers into three groups. So they had the high immune competence group, the average and the low. The animals in the high immune competence group, their health-related costs during that time at Talimba was $3.53 a head, versus the low immune competence were $103 a head. So it was, not only was it, it gave us confidence that the measurements were actually quite meaningful in terms of going through and reflecting differences in animals in the feedlot. Whether those same differences are reflective, I guess, on farm is the next part of the research which we need to see. But it certainly, based on those 1,100, the cohorts 2 and 3, it gave us enough evidence, I guess, to say that we think there's something in it and we should invest more in continuing this research. Richard, you know.
That's $103 a head for your third, $4, whatever. Is that just the raw cost of treatments, or is that an opportunity cost in there of performance as well?
No, I think there is also some deaths, which I think blow that out. I'd have to go and have a look at it, but of course you lose one. Yep. That's a big cost in there as well. So I think that's what really, but I have to go and digest that a little bit more. Dissect it, sorry. Okay, so that's the first part. As I say, I'll just give you a whole lot of snapshots, I guess. If you've got further questions and want to discuss a lot of this further on, then please grab Peter or I or Ashley or Liz as we go forward. Another key area which we're looking at is around our scanning technology. So at the moment, a lot of you will be getting scanners out where you take live measurements on live animals for fat depth, muscling, intramuscular fat, etc. One of the benefits, I guess, of the SIRO benchmarking now is we've got this really nice data set where we've got animals that have got scanning measurements, followed through and then got abattoir measurements, and we can start to go through and assess well, are the differences we're identifying with our scanning technology actually reflective of differences in the abattoir when we hang these carcasses up? So we've been doing some work with the centralised ultrasound processing lab in Iowa in the US. So the way scanning works in North America is slightly different to how it works out here. So a lot of you are familiar out here, you get a scanner out, they take some measurements on your animals, so they capture some images in the crush, and then there's the software crush side basically which interprets those images and produces the measurements, and you get the measurements straight away. In North America, how it works is they've got people that come out, they take those images, but then they send those images off to a centralised lab, and the lab interprets those, produces the measurements, and sends those back to you 24 hours later. So what we've been able to do in this program is our scanners, when they've taken those measurements, they've given us our crush side results, but we've also captured those images and sent those over to the cup lab and compared, I guess, the measurements which the cup lab gives us with the ones that we're getting crush side. So there's a couple of key messages to come out of this straight away. The first thing is it's showing our crush side results are doing a pretty good job. So the first thing is our scanning, the differences which animals basically which are being identified are being reflected in the abattoir. So it gives us a lot of confidence that everyone's investment in scanning, as we would have hoped, is doing a good job of identifying genetic differences in carcass traits. But within our CUP, it's probably identified some areas where or given us some encouragement that we might be able to improve what we're doing a little bit. So to date, we've gone through, I guess, in this space, and we've sent images on all cohorts 1 to 3 animals away, and we've got those results back. Cohorts 4 to 6, we've collected them, but we haven't sent them to the lab at the moment. And we're currently going through and analysing those cohorts 1 to 3. And what it's showing us is, I guess, it's still very early days in this analysis, I should say, and we've only really looked at IMF. So we're only really looked at marbling, we haven't looked at muscling or the 2 fat depths at this stage. But the early kind of indications, and our colleague Christian Duff has a paper which he's presenting in February at a conference next year in New Zealand, is showing us that in terms of our phenotypic relationship, so when we look at a measurement on an animal and then the measurement in the abattoir, the CUP measurements are lining up a little bit better and have slightly higher heritability than our crush side results. The genetic correlation, however, so how well that the scanning technology is actually identifying genetic differences in animals, is very similar. So it's looking like we might have some marginal improvements, but we really need to further analyse this to see whether it's worth exploring or not. So that's just an idea into I guess, some of the work we've got where we can analyse some of the outcomes from the carcass side of things. A bit of other work which has been added onto this and has been led by the New South Wales DPI. So we have Matthias Savez sitting in the audience today with us, and they've been a key partner in starting to go through and look at a lot more retail beef yield data. So one of the areas where we're lacking in the Angus breed plan analysis is actually having boned out carcasses, where we're measuring the amount of saleable meat yield in each carcass. So we've got a retail beef yield EBV. A lot of that's been based on some genetic correlations with other related traits based out of the beef CRC. But within this program, which has been led by New South Wales DPI, we've been actually able to go and collect some boned out data on modern Angus genetics. So in this, to date, we've collected some boned out data on 156 steers in cohort 5. So the New South Wales DPI is actually a collaborator within our SIRO benchmarking program. So the research stations at Trangie and Glen Innes are cooperator herds, and the steers which were bred on those 2 operations in cohort 5, we've gone through and collected this boned out data. So all the steers go through and they get killed at John Deere at Warwick, and they actually get pulled off the main production chain and go off into a separate room where we have some specific kind of boners and people all lined up, and they comprehensively go down and break down these carcasses and measure effectively the amount of fat, the amount of trim we're getting, the amount of bone and the amount of saleable meat yield. So I'll show you some of those results. It's quite a meticulous process, so we can only actually do 50 kind of steers a day, so it slows it down a lot. This is in John D, for those of you who've been there, is putting through hundreds and hundreds of carcasses through their chain in a day, and this is off, and we're actually only dissecting a side as well. So it's 50 kind of sides a day is all that can be done. The first work, these 156 steers, is a lead in. New South Wales DPI have been successful in securing funding to collect retail beef yield data on 100 modern Angus cattle. So we're hoping to collect that on cohort 6, 7 and 8, particularly from Trangie and Glen Innes, and then top that up with steers if we need to from other cooperator herds. So to give you an idea of the data that has been collected, so this gives you an idea. I think there's 153 carcasses here out of those 156. You can see we actually get a weight for each individual primal. So we get broken down across each of the primals, plus all the amount of trim and bone, which ultimately we end up down the bottom with the amount of saleable meat, retail meat from the side and a percentage, the amount of percentage of bone and the percentage of fat. So as you can see across here, across these 153 steers, there's quite a bit of variation in yield. So on average they're yielding out at 72%, but that ranges from 69 to 75. Same as bones, on average 21, but again from 18 to 23, and the fat on average 7, but ranging from 3.5 through to 12. So there's a lot of variation between animals. We know from previous research that's under genetic control, but this will just give us some more modern data to really refine our genetic evaluation and improve the calculation of our retail beef yield EBV. Alongside of that, getting the actual boned out data, for those of you that read general industry communications and things at the moment will know there's a lot of industry research being put into more objective assessment. So camera technologies and things where we can measure things in the abattoir. And all these steers within the CSIRO benchmarking program are having comprehensive image data collected from the different cameras. So an idea of the different cameras, they all get taken, a whole lot of images from all sorts of different angles taken on them. But there's some RGB cameras, which I think are New South Wales DPI cameras as well. They're looking at body composition. One of the benefits of these RGB cameras is they can also take body composition information on live animals. So that's showing some promise. There's some MIJ cameras which are kind of been developed on Wagyu cattle in Japan. So they're cameras which start to really break down and look at the marbling in a bit more detail. So not just the amount of marbling, but also the distribution of the marbling through the muscle, the fineness of that marbling as well. And some more data which MLA is starting to collect now through their MSA program is on some hyperspectral cameras. So there's a whole lot of other measurements that we're taking on these carcasses and data being collected in industry projects which will be of value to us. Taking the carcass side just a little bit further, one of the most recent bits of research which we've just started as well is starting to look at the nutritional value of Angus beef a little bit. So in particular those 156 carcasses which we got the yield data on, we've also taken meat samples on those, sent those away to the meat science lab to start to look at kind of the nutritional value of those meat samples. So say take measurements such as their fatty acid content, and their iron and zinc content as well. So they've been sent away down to a lab in Wagga. Those measurements have come back and we're really only just starting to look at those, but the early kind of analysis of it shows that there are differences between animals. So we don't know whether those differences are under genetic control or not, and we've only got 156 records, so we're only just dipping our toes in the water. But it has shown that there are differences between animals and given us, I guess, enough justification now to collect more measurements and start to explore this a little bit more. So obviously starting now to take this right through to looking at the consumer level and differences that we might have between animals in the nutritional content of the progeny or the meat of their progeny which they're producing. This work, for those of you that know Christian Duff, our strategic projects manager, this has been undertaken as part of his PhD that he's undertaking at UNE. Okay, so moving away from the carcass side of things, looking at some of the other work that we're starting to now do. Obviously one of the main areas which has been identified for Angus cattle as an opportunity for both for our members and also for the breed as a whole is through the infusion of Angus genetics into Northern Australian production systems. So when we start looking at our national beef herd, if you like, there's 55 to 60% of cattle are now based in Northern Australia. And most of our members and most of Angus cattle, as you're aware, are kind of based in Southern Australia. We have a lot more Angus genetics now starting to go north. But obviously one of the key things is we need those Angus genetics to be able to accommodate the hotter, more humid environments and with the additional parasite challenges. So with all our cattle predominantly being bred in the south, what work can we do to ensure that we're producing Angus genetics which might be more suited to going into Northern Australia? Some of the work which has been done, and this project has predominantly been undertaken by Ashley Horn as part of some of the studies and research which she's been doing. So the first kind of area we've been looking at is coat score. So there's a well-held view out there that animals with a slicker coat are able to have better heat tolerance and better performance in those hotter conditions. So we've started to put some research around that to see whether that is actually the case. So the first part of this is all the steers and heifers in the sire benchmarking program have had a coat score collected. So coat score being a kind of subjective assessment of the hair length and fibre diameter of animals. So you can see here the coat score 2, where they're more the slicker coat versus the wild and woolly coat scores 5 and 6 on these animals. So starting to collect information on cattle, which is similar to, I guess, what we're doing in the sheep industry on some of our merinos and things, but starting to look at coat type. To give you an idea of some of the results of this, so first of all, there's variation between coat type. So that won't be a surprise to many of you that observe your cattle, but we do have a variation from 1 to 4 at the extremes in coat type. And the work that Ashley's been able to do has shown that not only is there variation between animals, but there's quite a lot of genetic basis to that variation. So we have heritabilities of quite high heritabilities of around that 0.4 kind of, I think the latest estimate is around 0.43. So that's given us some, I guess, where that data is up to. We're now starting to go through and look and see, well, does the differences in coat score actually have a correlated effect with performance traits? So do animals with the slicker coats also have the better performance? One of the limitations of where we're up to is all these animals have been run in Southern Australia. So predominantly they're in northern New South Wales and Victoria and things. So really to take this research to the next level, we need to go and start to test this up in hotter conditions to see, are the variations that we're seeing actually related with and proving that I guess long-held view that slicker coats do have a better performance in those northern environments. It's in the short term, what I'd expect to see is we'll probably end up with research EBVs for coat score on animals in the sire benchmarking program fairly shortly. So that's a snapshot. Obviously due to time limitations today, we can't go through all the different R&D, but hopefully gives you a bit of an insight. To give you some of the ideas of just some of the other work that we are doing though very quickly, we are working, as I said, far more with our North American colleagues around international genetic evaluation. And that doesn't mean we'll go out and run a weekly or a fortnightly genetic evaluation in association with North America, but it just means we're in a process where we're trying to identify, I guess, where we can better identify Angus genetics within the global gene pool that might be suited to us and what opportunities there might be for that. So we have some data sharing and some collaboration on different projects, but really aiming to give us better selection tools with which we can identify those genetics that will be the most profitable for us from within the global Angus population. We're doing a lot in the net feed intake area now and feed efficiency. So in particular, all the steers in the sire benchmarking program go out to Talimba, where they're under, by the time they do their adaptation period, they're basically out at Talimba for 100 days on feed. U&E are doing some work on really trying to look at, are there ways we can more cost effectively measure net feed intake. We're also, I guess, working with CSIRO now to start to look at how can we collect feed efficiency data on animals on grass. So CSIRO have developed quite a neat way of assessing the feed efficiency of animals on grass. So they have the collars which they put on animals, which have got a little device in them which measures the grazing behaviour of animals. So it's a little bit like a Fitbit, similar technology for those of you that wear a Fitbit around to tell you how many steps you've taken and whether you're going to live to a ripe old age or not. It's similar, it measures the number of kind of jaw movements, their grazing behaviour and their heads down. Takes a whole lot of different measurements which they've been able to turn into an assessment of different amount of feed intake. So we're hoping to do some work in that space on these animals, particularly in the weaning, so post-weaning, get the differences in feed intake when they're on grass. The steers then going into limber, getting their measurements, seeing the relationship between those, and then the females coming through as getting measured again as mature cows to see what the relationships between all those measurements are. Vetoquinol are starting to look at some of our improvements in our reproductive programs. So particularly they've done some work looking at the influence of having different levels of progesterone in the synchronisation program. Doing some more work with U&E now on developing DNA genomic predictions and some genomic tools, particularly around the hard to measure traits. So a lot of the routine work, as we'll talk about through some of the different sessions today, the DNA will get the most value out of it from within our Angus breed plan genetic evaluation. But looking at some of those hard to measure traits which we're not routinely analysing in Angus breed plan as to where there's some work, some tools we can come up with there. We also have a project with Zoetis at the moment regarding maintaining our imputation accuracy. So for those of you that are familiar with some of the genomic tools that have come out of Zoetis, in the past we had an HD50K product, so it was a high density product. A couple of years ago that was rolled over to an I50K product, which is a low density. The key thing for us to be able to use those low density tools going forward is to be able to take a low density and basically infer or impute what the high density profile would have been. To do that we need animals with both low and high density. So we just are investing in this space where we're going through and collecting high density profiles on all the well used sires in the Angus breed to make sure that we can continue to utilise low density products as within our membership. And lastly, New South Wales DPI have also done some work on methane emissions. So when they're out at Talimba getting their feed intake data, some of you might have seen these methane machines. So there's some pellets which come out down here. The animals stick their heads in here and it's effectively a big vacuum, if you like, where it's sucking the air through and out and measuring the amount of methane that they're emitting while they've got their head in the chute here eating the pellets. So some of the work which New South Wales DPI have shown is there are differences between animals. Those differences are under genetic control. And particularly, I guess, where it's starting to relate differences in methane emissions to differences in productivity. So those animals which are emitting more methane are effectively not utilising their intake as efficiently and not turning it into as much production. So again, lower production. So that's a snapshot. Very quickly, there's a lot of work. It's quite a big part of what we're doing now at Angus Australia, and it involves a lot of both investment and day-to-day activity. In terms of where this will be, I guess, how do we turn that into adoption? So it's all good and well to do this, the R&D, but we need to actually be taking it out and giving it to industry so that you as our members can utilise it within your programs. All where we envisage the outcomes out of this R&D will be, I guess, delivered to industry is through our Trans-Tasman Angus genetic evaluation, so our routine evaluation, and the result will be EBVs for a wider range of traits, so better describing our overall breeding objective, and EBVs ultimately with higher accuracy. So ultimately what we hope to get out of all this R&D is selection tools which better identify and describe the genetics of animals, and particularly identify those animals with superior genetics, which will enable you as our members to make sure the next generation of Angus cattle that we breed are more profitable than the current population. And that's ultimately what we're all about, is trying to continually improve the performance and the profitability of Angus genetics within the beef production chain. How do you stay up to date? So in terms of if you're interested in these different programs and making sure you're up to date, there's a range of different ways which we're rolling this information out to people. So things like our national conference and our regional forums. So like this is a good thing. We're doing these on an annual basis. So it's a good way of keeping up to date. We do also have our weekly electronic newsletter, our Angus e-news, which encourage you, if you're not subscribed to that, to get on board. There's a lot of information which that come out and is put out through that e-news. Our quarterly Angus Bulletin publications, so it's sent out to all our members on a quarterly basis, often contains a lot of information about our latest outcomes. And then obviously our day-to-day, our website and our social media through our Facebook, Twitter, Instagram, YouTube. For those of you up to speed with all your social media, there's lots of information coming out through that on a regular basis. We do also now have the Angus Education Centre, which my colleague Liz Roan has taken the lead in producing. There'll be more and more education extension resources put out on that, the Angus Education Centre, which is through the Angus Australia website, which we'll have a lot more resources there as things develop into the future. So just some take home to conclude that. Basically, if you like, the Angus Australia now, I guess, has a large involvement in R&D, and hopefully you've seen that from this presentation. That's a collaboration of, combination, if you like, of in-house R&D between our SIRO benchmarking program, but more and more now a collaboration with other organisations. And the overall reason we're involved in it is to try and improve the profitability of Angus genetics.